Linux permissions. In Linux, the file system is a hierarchy of directories, subdirectories, and files. So how do we as a user control what somebody can read, what someone can edit, whether you want no one to be able to go into a certain directory or you want to share the directory with another member of a team? All of that is controlled by controlling permission. So it's one of the very important topics and very exciting because it gives you the ability to control what gets looked at, what other people have permission to do, and what they don't in your directories and files. So first, let me just show you what file permissions and directory permissions look like. So here, when you use the ls-l command, so far, we've been ignoring the first part of what you see here. You know what this is about, who's created it, what the group is, how big the file is, what the date and time is, and what the name of the file or directory is. That you already know. What you don't know, and what we've not discussed so far, is what all this pertains to. Now, this is where permissions are visible. So, first thing you'll notice is that the first character here tells you whether it's a file or a directory. So anything beginning with the D, which happens to be color-coded blue, but that's not always going to be the case, but that says this is a directory. So all these four are directories and the others are files. So in Linux, the permissions are dealt with in three communities. So first character you're going to ignore, that just says whether it's a directory or a file. But then there are 9 other characters after that. So let's look at a directory, for example. So you've got rwx, that's 3, r-x, so 6, -x. So total of 9 characters here. And the same thing with files. After the first character, which says it's a regular file, there are 9 other characters. So these 9 characters, whether it's a file or whether it's a directory, they are dealing with permission in groups of 3, and these 3 are referred to as 3 communities. Let me explain with a slide here. So the first 3 characters will pertain to a user or creator. In other words, if I'm making that file or I'm making that directory in my own account or subdirectory, then I'm the user or creator of that file or directory. So if you look at the permissions, the first 3, so for example here, R, W, X, these first 3 characters are to do with the user or creator permissions. So if I created it, they pertain to what I can do with that file or with that directory. The second group of 3 pertains to what's called a group. So everyone in the class, for example, has been set up to be in one particular group. If you look at the files or directories here, then r-x. So this next set of 3 pertains to what the group can do, and we'll discuss that in a moment. And finally, the last 3 characters here pertain to other. So there's 3 communities: user, think of it user creator, group, and then everyone else belongs to other. And the permissions can be represented, as you just saw, with R or a W or an X. So let's look at what that means in the case of a file. So R means read. You're able to read that file. What does that mean? So if there's data in there, you can read that data. If there's a few lines written in there, you can read them. And the commands that you already know which allow you to do that is cat, head, tail. So for example here, if we look at, let's say, the names file, at this point, what are the characters representing my permissions? Because I'm the user creator for that. These 3, right? R, W, and dash. So R is there, which means I have the read capability. So in this file, I should be able to do a cat or a head or a tail. So if I say cat names, it lets me see the content. If I say head, and I'm going to look at the first 3 lines, of this file, it lets me do that, and tail. So those are the common commands you will use to read the content of a file, and that's only allowed because I have the R or read in that. Let me just show you something here. So let's say I make a copy of this file names and I copy it into names2, and the reason I want to do that is because I want to show you the difference here. So those are the two same files, but I just copied name into names2. Sorry, names2, there we go. So I have the read here, and you already saw I can do a cat, head, tail, etc. But what if I took away that R? If R was not there, what happens? And we're just going to learn in a bit what the command is, but for now, let me just type that. So I'm going to do a change of the permission. So don't worry, we'll learn about it in a moment. So chmod is the name of the command I'm going to use. And I'm going to say, you know what, for the user, which is me, I want to take away the read, so -R, and I'm going to give the name of the file. So what am I saying here? I'm saying do a change of the permissions. And what am I changing? For the user, which is the first three characters, these ones, R, W, and dash, I want to take away -R, take away the read permission, and which file I'm talking about. So now if I repeat the ls command, you can see that in the names2, I no longer have R of a read, whereas names still has the R. So while I can say cat names, because names does have R, if I try to say cat names2, it says permission denied. So although I copied this one here, but I changed the permission so that the read permission is no longer there for me, and now I can't read it, even though there is data. So that kind of gives you an idea of how R permission or the read permission works for a file. Pretty straightforward because you're reading the content of a file. W is that you want to be able to write into the file. So think of it as changing or editing the content. And how do you do that? Using any editor. We learned about the VI editor, so we can use that. If W permission is there, you can change the content. So again, let's go back to the files here. So as you can see in both names and names2, I do have the W permission. That means I can go ahead and edit them. So let me just go VI, names, and when I go here, I can add if I want to, new name. And I save it. And now, of course, if I look at these and then I cat names, the new name that I added shows up. And this is possible because I have the W permission for me, which allows me to write into that file, to edit it, etc. So with the W, if you take away the W, you're not going to be able to change or edit the content of that file. The third type of permission is X, which stands for execute. So certain files that we're creating so far, they tend to be just text files. But when we do scripting later on, we'll see that we can actually make it executable and run that as a program. So I've just created one of the script files. So let me just go into this one here. So one of the files that I have here is F3, and I've made this into an executable file, which means I can run it. I made it into a small, tiny script, and we'll learn about scripting much later, but just know that a script can be run. It's an executable. So how do I run it? I simply say /F3, which is saying from the current directory, please run it. And it's running it. So it just prints out a line that says this is an executable script, and it goes ahead and lists the files that are there. So regardless of what the content of the script is, the point is I'm able to run it because I have the X permission. If I try to run a file which does not have an X permission, it won't let me do that because it's not executable. So for example, I cannot say something like /F1 because there is no permission and it says permission denied. Why? Because F1, as you can see, for me, which is these 3 characters, it does not have the X permission. Similarly, in this one, in F3, which currently I'm able to run, right? I was able to run it, but if I take away the X, I won't be able to run it. Even though it has the code to make it into a script, if I take away the X, I won't be able to run it. All right, so R, W, and X are pretty straightforward for a file permission. But the interesting thing is that even for directories and subdirectories, the same set of permissions are used, R, W, and X. However, there's a slight difference on how you need to understand in terms of what these permissions do in a directory. For example, an R or a read permission in a directory means that you're able to read the content of that directory. Because what is a directory? When you look at a directory, it's just a listing of a bunch of file names, right? So to read a directory means you'll be able to list the content. You'll be able to list whatever's inside the directory. In other words, ls command that you already know can happen if R permission exists, because ls is saying list the contents of the directory. So if I go here, one of the directories I have is D1, so I can say ls D1 and it lists the content of that directory. The W permission is more complex. What W permission does is that it allows you to change or edit the directory content. Just like W permission in a file let you edit or change the file content. So what does that really mean in a directory? Well, what would make a change? What would make you change something in a directory? If you, for example, create a file, if you add a file in a directory, or if you delete a file in a directory, what is happening? The list of files that you're going to see will be different, right? So that means you're able to change or edit the content of that directory. If you rename one of them, you're changing the content. So if I go here, all of these things are contained in one directory. So if I add a file here, the content of directory is changing. If I rename one of these files, it's changing the content of the directory. So commands like creating a file, deleting, copying, renaming, whether you're doing this to files or subdirectories, anything which changes the list that you look at in a directory, the list of files and subdirectories, anything which changes that will mean that you're changing or editing that directory. So W is what allows you to do that. If the W is taken away, you cannot change the content of that directory. So let me go here. So where am I right now? I'm in d-perm. So if I look at what's there, I have some directories and I have some files. So if I look at what's in the D1 directory, I have another directory and a bunch of files. Actually, if I do a tree command with a -p, it shows me what the permissions are as well, which is more useful. So in the directory that I'm in, I have a D1 directory, which in turn has D100 directory and 3 files, right? So if I wanted to change the content of this directory D1, I'm able to do that because it has a W. So that means I can actually maybe add a file here. So let me do that. If I just do a touch command and I'm saying go inside D1 and make a new file. All right. So now if I repeat my tree command, you'll notice that the new file just got added. So what has happened in terms of the content of the directory, D1 now not only has these, but it has an additional file. So I've been able to change or edit the content of that directory. And why was I able to do that? Because I have W in that directory. So D1 has W, which means I can change the content. If I took away that W, then I won't be able to do anything that changes this content. So let's say I want to delete that file. If I take away this W, I won't be able to delete that file because the directory that's holding all this stuff is not having the W permission. So let me take away the W there and we'll see what I'm talking about. So right now I can actually delete. So let's say I created this file, but I'm saying, oh, I don't want this file anymore. So because I have W, I should be able to delete it. Let me do that. So RM for delete, right? I'm going to go into D1 and I'm going to get rid of this file. So if I do the tree command again, it's gone. It's not there. I'm just going to add that quickly. So when I look at it now, it's there again. I just added that. So now if I take away the W from this directory, that means for my permissions as a user creator, if I take away my W, then let's see if I can still delete this file. I will not be able to. So I'm just going to change. So change mod for the user, take away W, and this W is being taken away from the D1 directory, right? So change the permission for the user, take away the W, and this needs to be taken away for the D1, which is the directory that contains this list, which I'm going to be wanting to change. All right, so now let me do the tree command again, and you'll see that the W is gone here, right? So now this means that I cannot change this content, which means let's say I want to delete new file. I can't do that because that would change the content of the directory and I don't have the permission to do that. So if I do an RM command and I'm saying go in D1 and new file, so I'm saying remove inside D1 the new file, and it says permission is denied. So I cannot delete it, although just a moment ago when we had the W here, it did allow me to delete it, right? So that's the difference with whether or not W is there. X as well, so if you look at the X permission for a directory, that also has a unique meaning for the directory because it allows you to enter or access that directory. So think of it as allowing you to do CD. You know how we do CD and the name of a directory? That's only possible when we have the X permission. It's also called the pass-through permission because it lets you enter the directory and pass through to the next level. So let's go back here. So if you look at D1 again, the fact that I have an X permission here means I can enter this directory. If I took away that X permission, I would not be able to enter that directory. So right now I can say CD and D1 and there I am. So now I see all of these, the D100, F100, F200, F300 and new file. I see all of these, right? Go back up. And if I now take away the X permission, I will not be able to do what I just did. So let me change the permission. So change mod. From the user, I'm going to take away the X permission for the D1 directory. And now, so the D1 directory no longer has the X permission, as you can see. Can't see that anymore. So if I try to do CD and D1, it's, oops, sorry, CD and D1, it says permission is denied. All right, let me add that back. So I'm going to go back and do a plus, which is going to add that back to D1. And now I'm back to where I was. Now it has the X permission and I'm able to pass through into the D1 directory. So I can CD again into the D1 directory. All right, so it's the pass through permission. Now the directory permissions also play an important role in deletion or renaming of a file. So for example, if you have a directory which has a W permission and a file which has a W permission, then you're able to delete that file, which makes sense because W for a directory means what? It means that you can edit the content or change the content of the directory. So if you want to delete an existing file, that's changing the content of the directory, right? So if directory A has W permission, and if you look at the file, it also has W permission, which means you're able to edit, change, etc. Directory has W, file has W, allows you to delete that file. But the interesting thing is this: if directory has W, but file does not have a W, then what are we saying? We're saying the directory says, yep, go ahead and change the content, which means you can delete if you want whatever's inside. But when it tries to delete, the file is saying, nope, don't delete, because when you don't have a W on the file is kind of write protected, as they say. So can you delete the file in that case? Well, the important thing to remember here is that the permission of the directory takes higher priority than the permission of files inside it. So it's like the parent and the child. The parent says, yep, go ahead and delete, even though the child or the file A here says don't. The parent permission is going to take precedence. It's going to take priority. So you're still able to delete that file. But it does ask you. So there is a pause. It'll ask you, do you really want to delete? And you have a choice at that time. So let's look at this interesting scenario. So this is, let's again look at this example. So we've got, let's add the W back here first. So if there is no W, I can't edit anything anyways, right? So let's look at a case where directory does have a W. So I'm going to change mod. And for the user, I'm going to add the W to D1. Where am I? PWD. I'm already in D1. I need to go out a level. And now, if I do a tree command, so for the D1 directory is what I want to change. So right now for the D1 directory, I do not have W. So let's add that. So change mod. For the user, I'm going to add the W for D1. And now when I look at it, I do have the W. All right. So the directory D1 does have the W. If I go in here, now inside D1, I have all of this content. So let's say the new file also has W. So now I have a case where the new file has a W. New file is sitting inside D1 and D1 has a W. So we're back to this case. Directory has a W. File has a W. So let's try to delete new file. So I'm going to say RM and go into D1 and delete the new file. And it has no problem. It's gone. If I look at the tree, it doesn't have the new file anymore. So why was I able to delete? Because D1 had the W and the file had a W. Let's look at this file, F200. F200 does not have a W. So now D1 has W, but that one does not. So where am I? I'm in the D perm. Let us look at the tree command. So for D1, I have the W, but file 200 does not have a W. So what happens now? If I try to say remove, go into D1 and remove F200. So D1, the directory, has W, says, yep, go ahead and change, edit content of what's in the directory. But you're trying to delete F200, which is this file. And the file does not have a W, which means it's write protected. So normally you wouldn't be able to delete it, but because the directory in which it's contained says, yep, you can. So see what happens. See, it's kind of prompting you and waiting for your input. So it says it's an empty file, but it's a regular empty file, but it's write protected, which means does not have a W. Do you want to still delete it? If I say no at this point, notice that it will not delete it. So if I do the tree again, it's still there. See, F200, well, I was trying to delete, but it's still there. If I repeat my command, I'm saying, yep, go ahead, and I say yes, go ahead and delete. Look now, when I do a tree command, F200 is gone. So even though it did not have a W, I was able to delete that because the directory D1, which is the parent directory for that file, said you can go ahead and do that with a W. All right, so important to remember that the directory has a higher level of permission. It's a higher priority, and it controls the deletion and renaming of files. The other thing to understand in directory permissions is that because of the hierarchical nature, the permissions are inherited. So it's passed on to the directory under, and under it affects all of that. So if you want to see the permission of the directory that you're in, you can just do ls with a -ld, and it'll show you of the permission of whichever directory you're in. So I'm in d-perm. So if I say ls-ld, it's showing me the dot, which is current directory. For me, current directory is d-perm. So those are my permissions for that. So ls-ld will show me the directory permission for the current directory, wherever I happen to be. If I want to look at specific permissions for a particular subdirectory, something that's underneath where I am, then I can give that name as well. So for example, I'm in dperm, but maybe one of the directories under that is D1, and I want to look at the permissions for D1. So then I can go ls-l D, but then I'm just going to say D1. Now it's showing me the permissions for D1. So ls-ld by itself is showing me permissions for the directory that I am in at any time. But to look at a permission of any directory underneath that, you have to give the name of that directory if you want to narrow it down. And lastly, if you don't put the D here, if you leave the D out, then it'll show you everything from directory 1 and everything underneath it. So in this case, let me just take away the D here, and now with the D it just showed me D1, right? But without the D, it's showing me for all the stuff that's inside. So that's the difference in these three commands. There's two ways you can change permissions. So you already saw me doing chmod and something like this, where I say that for the user, take away W, for example. These are just other ways of doing it. So this is called symbolic method. So if I say chmod, so far what you saw me do was u minus something or u plus something. So I'm only affecting the user permissions. But if I want to affect the group permissions or the other permissions, I can do G or I can do O or combine them together. So what is this saying? This is saying change the permission for the group and for other. So which permissions are we talking about? We're talking about these are for user, right? The first three. Then group is these ones, r-x, and then x -x is the last. So user, group, other. So we're talking about group and other. Those are the permissions we're talking about. So in this case, it will change permissions for group as well as for other. And what is it doing? It's adding r as well as x. So you can add more than one things all at once if you wanted to. And what is it affecting? Whatever you name here. So in this case, file 1 will be receiving an additional r and an additional x for the group as well as other. You can also do these separately. So in this case, what are we saying? We're saying to the group permission, add x. So if it was rw, it'll now become rwx. And it's saying for O, which is other, take away the W permission for this file. So you can combine those. And this is an example where for both group and other, you're doing the same thing. So you're saying G as well as O, take away W, add X. So quite straightforward here. If we do the tree command. So for example, let's say we want to change permission on F100. So chmod, and am I changing user or group or other? Let's say I wanted to change user as well as other. So I can go U and I can go O, both. And what do I want to do? I want to add X. So it's going to take user permission and add X, and then it's going to skip all the way to the last three and add X here, if that's what I'm asking it to do, right? So it's adding execute permission to user and other. Where am I? So I need to go inside D1 to do that. There we go. So I had not given the correct path. That's why it was causing a problem. So if we look at this again, now you'll see that it has added X here for the user and added X here for other. So we were able to do that by using this symbolic notation. So the symbolic method is quite easy. In this example, we're saying O equal nothing and star. So what that means is you're saying for other, the permission should be nothing, which means it'll be dash, dash, dash. And star is just saying for all files in the current directory. So here we were using plus to add permission, minus to subtract it or take it away. Equal replaces it. So it wipes out all the permissions and replaces it with what you're saying. So if I said O equals Rx, it's going to go to other permission, and whatever it is will be wiped out and it'll be replaced with Rx, for example. If I'm here, and let's say I want to, let's go to this one. So F100 at this point is, for the group, it has just R. Maybe I want to add W here. So what am I going to say? I want to add W to the group. So group equal. So when I add W, then the group should be R and W, right? Those are the two it should result in. So I can say equal RW. If I look at the tree, I've added W here. So you can say equal, but then you have to give all the three permissions. So RW, you don't need to put dash. So it'll be R and W. But if you were adding W by itself, you can say R plus, you can say group plus W as well. So plus will add to existing, minus will take away from existing, equal will wipe out what's there and replace it with what you're saying it should be. And the second way of handling permissions to be changed is what's called octal or absolute method. So not to be confused with the term absolute in terms of path, nothing to do with absolute path. All right, so just the name for the second way of doing permission change using octal numbers. So when you say absolute method, what you need to remember is that is the octal method. So I always try to put octal absolute. You might see one or the other if you're reading about it. So let's see how this works. Again, we're dealing with the three communities, the user or creator or owner, the group, and other. So let's say the existing permissions are these: RWX for the user, R and X for the group, and other also R and X. Now, one thing to remember is that these are always in the same position. In other words, if W is missing, then the dash will be in the second spot. W is not going to be in the third spot. R is always in the first spot, W always in the second spot, X always in the third spot. So they're position dependent. Now here's where your octal number and binaries come into play. So whenever the permission is there, for example, R is there, W is there, X is there, so the permissions are all there. Permission is there, you put a 1 under it. So 1, 1, 1. Here, permission is there, but here there's a dash, which means no permission, so you put a 0. X is there, so you put 1. Similarly here, it's 1, 0, 1. So if you think back, this is a group of 3 binary digits, right? And what is the relationship with 3 binary digits? It makes 1 octal digit. So if you think back to how we converted them, 111 would translate to a 7. If you forgot how to do that, you can review the video or the notes for numbering systems again. 101 gives you, in binary, gives you 5 in octal and 5 in octal. So what we're really saying is that if we give a permission of 755 as the octal number, then we really want these permissions to come into play. That's what we're saying. So in the chmod command, instead of saying, with the group, take away this or other, add this or make it equal to this, that's the symbolic method. But if we put this number, so we're saying do a change such that the permission should be an octal 755 for file 1. So what we're really saying is that's the permission we want. So the permission ends up being this. Similarly, if we said 644, so I want you to just think for a moment in your mind and convert 644 backwards to see what the permission is going to be, all right? And you'll find that it gives RW dash to the user, and the group and the other will have an R dash dash. So that's an interesting exercise for you to do yourself. If you want to make changes, by the way, if you said 777, you know that each one of these will be 111, again 111 and 111, which means you're giving RWX to user and group and other. So it's kind of dangerous because it lets anyone from your group or anyone outside the group to make changes or delete, right? Because you're giving them W access. So that's usually not a good idea. But I put that in there just so you know that you can put any octal number anywhere from 0 to 7 in order to make these permission changes, and they will be reflected based on what number you're putting. If you want the change not only to one level, but to all levels under it, then you can do a recursive. So chmod with a dash R, dash capital R, means it's going to make this change, give you RWX, RWX, RWX to dir1 as well as for everything inside dir1. So it's a very quick and easy way to change permissions all the way through the hierarchy. So let's just do one of these. So let's say for F300, I wanted to make it RWX, RWX, RWX. So I would go chmod 777 and name of the file we're dealing with. So D1 and F300. So now if I look at the tree, you'll notice that for F300, it's become RWX, RWX, RWX. So whatever octal number you put, if you convert that to what binary and what permissions it means, that's what you're going to get here. So let's do 755. So that would give you RWX, R-X, R-X, right? So if I repeat my chmod and I go 755, now if I do the tree command, you'll see it has RWX because of the 7, and then R-X because of the 5, and R-X. So when initially symbolic, as a beginner, symbolic may be easier for you, but once you get used to these octal numbers, many people tend to use these octal numbers to indicate permissions. In fact, in many of the scripts, you might see octal numbers being used for change to permissions, but it can be done both ways. And the last concept to understand is umask. And what that means is when you create a new file or a new directory. So how do we create a new file? You've learned the touch command or a vi command to get into the editor and save the file. So anytime new directory is created or new file is created, it automatically gives you a certain set of permissions. How does it know what permissions to give it initially? That's what umask is about. So for example, here, if I did a touch new file 2. So if I look at ls-l new file 2, we notice that it gave me rw dash, r dash dash, and dash dash dash. So why did it give those permissions? That's where umask comes into play. So if I type umask, it's giving me a 0026, which means ignore the first 0. So it's really these 3 digits, 026. So my umask is set to 026, and that's what's giving me this initial permission. And the same thing with directories. It's going to give me a certain set of initial permissions. So let's see how that works. So think of umask as being the opposite of permissions. And who sets it? Well, the administrator gives you a default umask. In other words, based on what your umask was set to by the administrator, that is what determines what the initial permissions are going to be when you create a file or you create a directory. So let's understand that. In this example, I'm assuming that when you said umask, you get a number that says 022, octal 022. So if that was the case, let's understand how that translates into permissions. So write down that number, octal number 022. So that's your existing umask. Then make that into the group of 3 binaries. So 2 in the binary would be 010. 2 again 010. 0 is just 000. So that's umask in binary. Now umask is opposite of permission. So what is permissions in binary? It's going to be the reverse. So where there's a 0, you're going to put a 1. Where there's a 1, you're going to put a 0. So 0, 1, 0, umask becomes 101 permission. Same thing here and same thing here. So here because 000 was in the umask, and so the permission will be 111. Now wherever there's a 1, the permission exists. Where there's a 0, you put a dash. So when you have a umask of 022, translate that into binary and translate that into permission by reversing it. And put the permission where there's a 1 and put a dash where there's no 1. So RWX, RX, and RX is going to be the permission of any directory, new directory that's created. So in fact, new directories and executable files will have these permissions by default. Now, what about regular files? So when you do a touch command and create a regular file, if you had this umask, the operating system goes one step further, and when you do a touch command and create a new file, it's a text file. It's not an executable file. So the operating system by itself will go and take away and drop these X's from here. So from this, it becomes RWX, it'll become RW dash. From R dash X, it'll become R dash dash, R dash dash. So the new, with the same umask, new directories and executable files will have this set of permissions, and then regular text files will have the same permission minus X automatically. You don't need to do anything different. The operating system will drop the X in each case. All right. So that's how what your umask is determines what your default permission will be for anything new that you create. So you can still, when you create something, change the permission. Umask simply deals with creating the initial permission for any new file or any new directory. Okay? All right. Thank you.